Welcome again. Now I will show you how we are going to resolve the problem that I have exposed. I have told you that quantum mechanics and general relativity could not be unified because of the square law that was misinterpreted. And to tell you the truth, it's not Einstein who's the source of the problem. But the reason we focus on Einstein because of the notion of relativity. And relativity was supposed to be the one to correct the mistake that was made 300 or let's say 250 years before Einstein. So this is what is very crucial here, and how we are going to correct this interpretation of the square law. So the singular numerical relativity comes for that reason, to complete general relativity. As we have seen with Galileo's experiment, we will focus only on numbers, because numbers are the fundamental building blocks of space-time. And the singular numerical relativity advises us to go and study the square law inside the black holes. Because how space-time works inside the black holes, we have to meet the king of all the numbers, which is the singularity. The singularity will tell us how flexible numbers are, because numbers are flexible. As the building blocks of space-time, numbers must be flexible as space and time are flexible. So this is logical. And we will be demonstrating to you exactly where this idea came from and how we arrived to this. But for now, because we are talking about the square law, we have to go now to study the black holes. Why? Because scientists believe that black holes is the place where quantum mechanics and general relativity are really connected. Inside the black hole, it says that the information card at a given level is directly proportional to the square of the level number plus 1. So we have this as our black hole. We see levels here. These are levels. You will understand why we need these levels. And here is the singularity. And on the surface of the black hole, you have a card, an information card. This is told to us by the holographic principle. The holographic principle says that when an object falls into the black hole, it will go straight to the singularity, where it will be crushed. Then it will vanish, all the content will vanish. But the information will be preserved on the surface of the black hole. That information is what we call the information card. It means what? When you go to the black hole, you stand there in front of the black hole, and you will like to identify what object went inside the black hole. the information card is there. It's like an ID. And that information card will tell you that the object that came here has, for example, 5 continents, 10 rivers. So you will have different numbers on the surface of the black hole. And each number gives you the details of something that describes the object that went inside. And that's what we call the information card. And if you want to know how many bits of information you will meet there on the surface of the black hole, you have to know simply the level of this surface of the black hole. Why we say level? Of course, this is something that the holographic doesn't explain. Because the holographic principle will tell us there is information here. But it doesn't explain how this information is maintained on a very dangerous place like the surface of the black hole. Because everything that gets closer to the black hole will be sucked in. But information can stabilize here. How come? The holographic principle doesn't have an answer for that. I don't know if they have tried in the past 3 years or, but there is no answer yet for that. The singular numerical relativity tells us that once an object goes inside the black holes, it will be crushed by the singularity. Crushed by the singularity means is when you click on the button of your camera to capture the image. And that's what happens here. All the information of the object will be captured by the singularity first and recorded here as one number. So the singularity here is a number. There are so many definitions actually which make sense, of course, about the singularity. It's not just one definition. We will call it also a small box of space-time that preserves the information of all the objects that fall into the black hole. Here we say that the information is first recorded here as one number, and that number is a huge number. It's a big number. Then what the black hole does, the black hole will process this information step by step, following the square law principle. The square law works here. So how it works? The singularity, which is here, is just one bit of information. Then this number will split or duplicate into 4 other numbers at the first step. 4. Next, it will duplicate at 9. Step number 3 become 16. Step number 4, it will become 25, 36, 49, 64, 81, 100, 121. So you go on. Depends on how heavy this singularity is. Because the heavier the singularity is, the deeper is the black hole. So this is really very important thing. So we say that the square law works here, saying that the information card at any given level is directly proportional to the level number plus 1 squared. So you have here information card, which is exactly the number of bits of information at that level, is directly proportional to n plus 1 squared. N means the level number. And as you are going to see it here, it shows that at level 0, we have only 1 bit. How to get that 1 bit? You have to get this formula. 0 plus 1 squared. 1 plus 1 squared gives you 4. 2 plus 1 squared gives you 9. 3 gives you 16. Give you 25. 5, 36. So you see the difference between what we have learned before through Galileo's experiment and all the square laws that we have learned before. They don't have this plus 1. And this is what the singularity is introducing to us. But before I will explain more about that, we have to see how exactly they are positioned, these bits of information inside the black hole. So if we go to the black hole, you see, as we have said, at first the singularity is just 1 bit. But the number which is here is very huge, because this number will be feeding all of this you see here as it goes on. This is the source of power. So the singularity is the source of power. And it will be feeding all this, following the law. As you see, it will stop wherever it can. So all depends on the capacity of this number here. When it goes, the first level, come 4. Second level, 9. Third level, 16. Fourth level, 25. And so on. So this is the real way the square law works. So if you go, for example, diving into the black hole, first, of course, this is the information card you will meet first. Here I made only three levels, so 2 levels from the singularity, because my space problem. But we could start just like the others. We could start by any number you want there. But here, as we start with 9. So if you go to you go and you want to go diving inside the black hole, what you will see first is this, the N. These are the bits of information you will meet. But behind these bits are also other bits hidden inside. So there is information inside that makes what we call the entropy of the black hole. You will meet it first. You will know in advance. When you have 9 here, it means you have how many open? This is called holographic card. Holographic information card. Why? Because we have open areas. You will be demonstrating to you how we get all of this exactly. but not this time. So please accept it as I give it to you. It says that you have these open areas which show us that the number of bits we will meet in the next level, which is lower, will be 4. That's, we have 4. And these 4 are separated by only 1. They offer only one possibility. So if you have to go inside again, so you have only one bit you will meet. And this is the singularity. So we have this holographic information card. The holographic information card tells us, first, the details. What you see in blue with M here, these are the details that you will read, the information about the object. But there is also the hidden information that you can't see, but you will see it through simply counting the number of entries here, where you can enter, you can pass through. So you have 4. Next will be 1. Of course, it follows the square law. That's why we call it holographic square law. So we have seen this. What is important to us is the correction about the square law. Because we have seen that the singularity can never be 0 or infinite. There is no such a thing. The singularity is always, so you can turn now. The singularity is always bigger, because that's the source of information. That's the source of energy. That's the source of light. That's the source of force. Therefore, at the force you get here, or the energy you get here, is big compared to what you get in this next, because it is reducing as light also. We saw when you start at the source, light is the intensity is very big. But when you move from the source already, the intensity of light become smaller and smaller. And exactly the same principle happens here. The number, the singularity, which is the big number here, this big number will split into into 4 numbers first. These 4 numbers are smaller than the singularity. The numbers here will be smaller than the 4 numbers here. So that's the principle we follow. Then, because of this, now we can make a correction. If we go back to this formulation, or this formula of Isaac Newton, if distance now is 0, what we see? Not infinite. What we get is the maximum force. Maximum force, because when 2 bodies come closer by 0 distance, that's where the maximum force is. Not infinite. Maximum force. And that's why if you put 0 here, you still have the maximum force. Even the intensity of light, if you put the +1 with the distance, of course, what you will get is the maximum intensity. So, intensity of light is maximum at the source. the attraction force is maximum at zero distance between the two particles. That's what it means here. So, what do you think? Is this idea wrong or good? So we have to correct. It is painful, I know, but the benefit that is coming through this, after we will have corrected the square law, then you will see yourselves the results. The singular numerical relativity doesn't come just to correct this. This is about simply telling you externally what is gravity. But it is a theory of information. We are talking about information. Therefore, we are not coming here to talk about kilograms or meters. That's not the point here. We are talking about numbers. Information is our guide to lead us in whatever we want to achieve. And that's why the singular numerical relativity will help us discover the universal map of information. And that universal map of information will show us how quantum bits work together. So if we go back inside this black hole here, all these are quantum bits. And they move together. Whenever there is a change made at the singularity, all move together. They adjust. Whenever change is made at the singularity, all will adjust at all the levels at once. Therefore, the power of computation will be very precise, faster, and whatever you want to say. We are moving towards perfection in information technology. And that's what the singular numerical relativity will provide. If you want to learn it better, you have to do it now. So I'm calling for the attention of all the scientists, the physicists particularly, to study the singular numerical relativity. This is the only way. And now that we have learned that we have to put +1, do not go and just apply, because you cannot justify that. You will not be able to justify it. To justify it, you have just to study the singular numerical relativity, because there is a lot to study. We will study about the Big Bang. I have not talked about the Big Bang, but what is behind the Big Bang? The Big Bang is something else, another level of energy. Therefore, it will show us how these things are useful for humanity. So I will encourage everyone to listen to what I have said today. Today is Labor Day. All the heroes of science are here to encourage you to listen to the singular numerical relativity, because this is the solution. There is no other solution except this. Whether you like it or not, and if you miss this opportunity, you will never have another like this. I am not saying this for me. I am saying this for the sake of humanity, for the sake of everyone. If we want to continue teaching mistakes to your children, then go on. But the correction will be made. Your children will realize later that this singular numerical relativity is right. Do not mind about my personality. Just focus on what I'm going to give to you, because I'm not doing it by my own power. I'm not intelligent, but I have this in order to help scientists to get out of the nightmare that they have gone through for centuries now. So everyone is invited to study the singular numerical relativity. Thank you very much.